In the previous class, we have studied about the first use of dimensional method. That is called principle of homogeneity. By using this concept, we can check whether the equation is right or wrong. Now, one more example is given here. This is actually called Waals equation. Right? This we will study in your chemistry. And here, see which are the terms. P stands for pressure of the gas, and V stands for volume of the gas. R is called the gas constant, universal gas constant, and T is temperature in the absolute scale. A and B are constants. Question is, what are the dimensions for A and B? You have to find the dimensional formula for A and B if this equation is correct. That is the question. So the aim is find the dimension of A and B from this equation. Here, which method you will use, or the concept to be used is again principle of homogeneity. You see, yesterday I told you 10 meter minus 2 seconds. What is your answer? Can you subtract? So subtraction is not possible. You can subtract only meter from another meter. So 10 meter minus 2 meter. V minus B. V minus B means dimensional formula for V and dimensional formula for B must be same. There is no second option. Both the terms must have same dimensional formula. Then only subtraction is possible. That is called principle of homogeneity. That is what I apply. You know dimensional formula for volume, that is length cube. So dimensional formula for B is L3. That is M0 L3 T0. This is a dimensional formula for B. Now you see the what is left now? A is left. Now here again you can see an addition. 10 meter plus 2 kilometer. Will you get the answer? So here also answer is not possible. Only meter can be added with a meter. Length can be added with a length. Pressure can be added with A by V square. Meaning dimension of A by V square and dimension of pressure are same. That's called principle of homogeneity. Now dimension for pressure. If you don't know, just think. Pressure is equal to force upon area. And force is mass into acceleration. Divided by area is length square. Is it right? Force is mass multiplied with acceleration and area. This A is area. Force upon area is called pressure. L square. Cancel. So your dimensional formula is ml minus 1 T minus 2. So principal pressure dimension, you can write ml minus 1 T minus 2 is equal to dimension of A divided by dimension of V square. Dimension of volume is L3. So L3 the whole square. What is L cube the whole square? That is L power 6. You can do the cross multiplication. Now you will get the answer. So dimension for A is, if you do the cross multiplication, your answer will be ml5 T minus 2. See, mass into length minus 1 into length 6. That is length 5. T minus 2. So this is a dimensional formula for A and dimensional formula for B. So the simple another meaning is this one. You can find the dimensional formula of a quantity given in the equation based on the dimensional method or principle of homogeneity. You can see another equation here. V is equal to pi p r raised to 4 by 8 eta. You have to check the correctness of this equation. Again you can see some new terms here. Here V stands for a rate of flow of liquid through a pipe, meaning volume of liquid flowing through the pipe in 1 second. Pi is 3.14. P stands for pressure difference. Pressure difference, meaning it is a pressure between the two ends of a pipe, and R stands for radius of the pipe. Eta stands for coefficient of viscosity. Pi p r raised to 4 by 8 eta m, where V stands for volume of the liquid flowing through the pipe in 1 second. P is pressure difference between the ends of the pipe. R radius of the pipe. eta coefficient of viscosity and L length of the pipe. You can check whether this formula is right or wrong. You know viscous force F is equal to eta A delta V by delta X. Here eta is called coefficient of viscosity. That is what we studied yesterday. So eta is F delta X divided by A delta V. Force, mass into acceleration into distance divided by A is area and delta V is velocity LT minus 1. So what you are getting, L square and L square cancel. So your power will be ml minus 1 T minus 1. This is the dimensional formula for coefficient of viscosity. Now how many terms you can see in this equation? There are only two terms. One is volume per second, another one is this full right hand side, that is a single term. Because already I told you terms are separated by plus sign or minus sign, not by multiplication or division. If the equation is correct, then dimensional formula for V and dimensional formula for pi p r raised to 4 8 eta L must be same. If both these dimensions are correct, equal, then equation is correct. And this one you see, volume of the liquid flowing through the pipe in 1 second, that is L cube by T. So the dimensional formula will be, there is no mass then, length is 3, time is minus 1. So this is a dimensional formula for volume of the liquid flowing through the pipe in 1 second. Now see the right side. Here you can see the first term is pressure. Pressure is force upon area. Force is mass into acceleration upon area. So your pressure will be ml minus 1 T minus 2. And radius, all of you know radius is a length and radius power 4 divided by 8. There is no dimension for 8, no dimension for pi. Now eta, the dimensional formula for eta you can see ml minus 1 T minus 1 into length L. Here it's very clear, L minus 1 and L cancel, mass cancel. What is left now? L for L minus 1. So it is definitely L3. T minus 2, T minus 1. So it will be T minus 1. And there is no mass term. See. So dimensional formula for V and dimensional formula for pi p r raised to 4 by 8 eta L are same. Therefore, the equation is dimensionally correct.